Yeah, 5/10, maybe a little bit more. This is, it would say it's 75, 0.75, 750, 75 thousandths, 75 tenths. Oh, okay, 7.5. That's what I meant to say. 7.5 tenths. Today, the time in the shop is going to be focused on measuring the vise for flatness, parallelism, and squareness to the best that we can with the tools that I have. This is not a toolmaker's shop. This is a garage, a home garage, a home shop. So we only have what we have. We're going to make it work. All right, I have spent a fair bit of time disassembling my existing working Kurt Vise. So throughout this video, you'll see that I've yet to master the language of the dial test indicator. This is accurate to 5/10,000ths of an inch, and all of the measurements that I'm writing down on the vise are relative to 1/1000ths of an inch. So if I write down 1, that means it's plus 1/1000ths of an inch, or -1, -1/1000ths. But then you'll see other times where I say it's half, or it's 50, or 5/10ths. But I might write 0.05, and it's just a brain freeze, apparently. So it took me a while to kind of go through and make this make sense. But if you bear with me and follow through on the video, I think you'll see that we ended up getting there as far as measuring out the accuracy of these two vices. I'm generally happy with the whole outcome, and I do appreciate you watching. Consider subscribing if you'd like to see more videos like this. We've got a range of almost 0.02 where it kind of drops down. And I'm getting about a little bit less, 0.5 thousandths worth of rocking. All right, let me come off there and test it one more time. 0. Let me bring you with us. I'm at 0 here. Down to -1. That's 1.5. 75. It's almost 2. And then up here on the part under the fixed jaw, -1.5. That's 1. Comes down a little bit here to -0.5, closer to -1. It could be almost a -1 now. I'm coming up towards 0. And then we go +1. So we're going to do two things here. One is I want to confirm the depth that I had cut off the top. And so, right now, this isn't even registering because I've cut down so much. So I want to use some gauge blocks and find out just how much I cut down. So I have a 50 thou, which I think is more than I cut off, but let's see what that does. Yeah, it won't go underneath there. Oh, it's at the max of the... I don't have a skinnier gauge block. So now do I have a feeler gauge? That's what I need. All right, I found my feeler gauges. I'm going to go right to 25 thousandths because that's what I think I took off the top of this. And let's see how close we are. Okay, so that doesn't quite bring me there, but it looks like it's would be 26, 27, 28 thousandths. So let's see if we have one of those. We do. And there we are at 0. So 28 thousandths brings me back up to 0. So I've taken 28 thousandths off of this guy. That's good to know. Minus a half. Okay. So we've got our most variation right here, kind of in this part. Let's see how much rocking we get here. Nothing that way. Nothing that way on that corner. On the number 1 corner, I'm not getting any rocking there. About 5/10. And less than that. Well, compared to the base, vise, yeah, this guy's in slightly better shape. That's a good start. All right, next up, let's take a look at the movable jaw. We have the restoration vise here on the left, and we have the other vise here on the right. So interesting to see how the design changes, where it looks like they've carved that off. And to put things into perspective, They're both the same D75, 675 vices. The restoration vice is number 15,127. So 15,127, and the other vice is 63,717. So this vice is 50,000 vices more experienced than this one. So they've made some changes as we've gone along. And as you look in here, you can see it says D675-2-CA. I'm curious what that means. And then here you have D675-2. So that CA represents some sort of a change. Another change that I notice on this one is the sticker is recessed. So they've machined away on the side of the jaw here an area for the sticker to go. Versus on the older one, even before I ground it, there's no area there for the sticker. All right, let's check these out. All right, the first test we're going to do is to check the flatness, or the flatness of the bottom surface in relation to the surface plate. So I know the surface plate is flat, and I've calibrated my 1, 2, 3 blocks, so I know that they are flat. So I'm just kind of lifting that plane of the granite surface plate up by using the 1, 2, 3 blocks. And I want to check for consistency on the bottom side of this vise. So I'm going to zero that out. All right, I'm at 0 here in this corner, again measuring underneath. I'm at 0 here. 0 and 0. Okay, so that tells me that this edge here is basically parallel to the surface plate, which means that it's flat. Take this, spin it around, and I'm resting this on the machined portion. That is about 5/10. That's about 5/10. 5/10. And 5/10. Let me come back to the front, make sure I didn't introduce any error. Five tenths, 5/10, 5/10, and 5/10. So maybe I introduced some error somehow when I measured that first time. Double check. 5/10, 5/10, 5/10, 5/10. Okay, so this is flat. This surface here is flat and parallel to the surface plate. Let's check this one. Now I do know that I took off 2 thousandths off of the bottom of this. See how that looks. That is measuring up at just over 5/10. Sorry, let me go back. The fact that I took 2 thousandths off of this surface is irrelevant to the test that we're doing now, but it will test to see whether or not I did it consistently. So I should be getting the same reading from the bottom of this surface to the bottom of the plate. So I'm at just about 1/1000, 5/10, 5/10, and 75. Yeah, so about 75, 5/10. I guess that's, let's see, check this side. 5/10, 5/10, 5/10, and 5/10. So this side looks really good. This side here. This side here is giving me some a little bit different readings. Let's check it again. Just about 1, 5/10. Just over 5/10. And just about 1. Let me check down the side a little bit, see what I see here. At about 1. Here on the back side, no, you can't see it, that's also about 1. One, 1, 1, 1. You know, I wonder if my variability is up too close to the edge where there's a little bit of scoring from the rust. It's still a half, and it jumps over here to about a 1. So it looks like I'm about 5/10,000ths, kind of after all 4 corners out of balance on this guy. That could be, I got some little bit of funky rust pitting still here. That will be the comparison of those 2 parts. Next, we'll check for parallelism with this top surface and the granite plate. Again, confirming we know the granite plate is flat. The 1, 2, 3 blocks are also flat and true. The bottom of this movable jaw is flat and parallel. And so now we want to take all of those consistent flatness assumptions and test for the top here. So I'm calling this flat between, 5/10 and 1/1000 of an inch off, but it's pretty good. All right, let's take a look at this guy. This has gone through a lot of surface grinding. And it has gone through a lot of deburring with that Scotch-Brite wheel. I'm curious if it is held flat or if it is not flat. And we did have to take a lot off of this guy. So let's do that first. If I come down here, yeah, it drops right off again. Consistent 6, 7, 8 again. Yep. Okay, so this guy is going way down this way, and so I'm really curious to go back and check that video and see how I had it lined up and to confirm. I do remember that it had one side, more than the other. That is why this top part should be ground with it mounted to the vise. I tried not doing that to prevent grit from getting into an assembled vise unit, but clearly you can see that's way out of spec from where we want it to be. So we'll be regrinding this and the fixed jaw after we have it mounted up. That is very interesting and kind of cool. It's fun to do the measurements and the math and see what things look like. And we'll just double check everything again. 0, 0, minus 1.5, minus 3. Okay. Get that feeler gauge out there again. Try 17 thousandths. Brings me very close. Looks like it's going to be 18 or 19. Let's try 19. Getting some variability there. It's about 19. 19 sort of works. It's not quite getting the same snap result I got on the other. Getting some volatility here in the results. Maybe even 20. Strange that would give me such a different reading compared to this, because they were ground on the same. Oh, but this one's also off by 8/10, so I guess that's probably not a good proxy for much of anything. 20 thousandths is bringing me back up to almost 0. Okay. All right, we'll do a quick check here on the bottom of the jaws. We're going to check for flatness in relationship to the granite surface plate. So I've got that in at 0. And we'll check it here, and we're at 0, and we're at 0. So that's good. That means that this is flat. Flat is good. Check the other one. 0, 0, and 0. Excellent. So both of the jaws are in good shape. So the next thing I want to check is squareness. Is the surface of these jaws perpendicular to the flatness that we've already checked for? I think there's a couple of different ways of doing this. I think this way is okay. I've got a square, which, as far as I know, is square. And, I've only checked that with these visually, with these 1, 2, 3 blocks, and I'm not getting any play here. You know, when I bought the surface plate, this square came with it. I don't know that it's tool room quality. It is the best I have available, so I'm saying that this is going to be square. And what I've done is with the surface gauge, I'm using this block here as a guide. And so when I put this up against the square, my tenths indicator is on 0. So that I know that when I push this system up against other things, if it comes back to 0, then I know that it is square in theory. So let's try that. See if this will reach, if I have the right height. Okay, so touch it flat on the bottom. Look down here, and it is just about back at 0. So that tells me that this is square. Actually about 1/10. Let's see. Reading that in, so it's actually coming in. Coming in towards me about, get our special glasses here. About 5/10. So now I just want to double check back at the square. So I should see 0 when I come back here. And I don't see 0 anymore. So my system has moved. Got to tighten everything up, and we'll come right back. Okay, back up against the square. I am at 0. Here we are at 1/1000ths. So it's pitching towards me 1/1000ths of an inch. And this says it's pitching 2/1000ths. All right, so let's go back and check against the square. That's basically at 0. And that is at 0. Try the other one. That is at 0. This is at 1, pitching out. So if this face is not square, when put on this bottom surface, which we have identified as being flat, I should be able to measure this with the surface gauge and see some variation. Let's check that again. So here we're at plus 0.5. Here we're also close. I got some volatility there. Very close to 0. So 5/10. Let's check this one. +1. And plus 1 maybe, plus 0.5. All right, so checking the Kurt Vise jaws. Let me give them a quick check here for any high spots. Let's see what these guys are doing. So got 0, 0, plus 0.5, plus 0.5, plus 1, plus 1. So I'm at 0, 0, 0, 0, and if anything, it's plus 0.25. Okay, so checking in on our measurements, and where are we? So we have the base. We have the bases, I should say. Where we have on the restoration vise, we have a plus 1/1000th of an inch from end to end. Seems pretty good. And from kind of side to side, we're at about 5/10 at the most. Yeah, 5/10, maybe a little bit more. This is, I would say it's 75, 0.75, 750, 75 thousandths, 75 tenths. Oh, okay, 7.5. That's what I meant to say. 7.5 tenths. And then over here on the kind of template vise, which I'm just using as a guide to try to get a sense of what's important and what's not, I've got a 0 to -1. We have -1.5 here. We've got a +1. So we're in that +1 to -1.5 range, kind of across the base. So that tells me that I'm pretty comfortable with the layout and the flatness of the base as it is. All that is to say, things might change when it's on the table. The table that you're setting this on is also an important piece of it, and how it reacts when it's clamped down. Coming over to the jaws is a little bit of a a different story. There's a handful of things going on here. My primary focus on the jaws is their squareness. So we want to make sure that the mating surface here, where it'll join up to the fixed removable jaw, we want to make sure that that it's parallel. Also, it would be good if the bottom was square to the mounting surface. I do think that the parallelism is important. If I'm looking at these, I'm anywhere from 5/10 to a full thousandths of difference in parallelism. And on this one, I'm about I got a bunch of zeros, plus 0.5, plus 0.75, so less than a thousandths on this one. And the Kurt jaws themselves, the actual ones that were on the template vise, this one's really nice. This one's 0.25 tenths, and this one is has a variance of about 1/1000th. So, within a thousandths of parallelism. Where we see a dramatic difference is on the fixed and movable. So on the restoration vise, we have this huge drop-off that's happening here. If we put this the way that it'll be mounted, so my zeros are here, and I'm exaggerating, but it's dropping off like that. And this guy's actually doing a very similar type of action. And if I remember right, when I go back to the video and see how this looked when we ground it, I'm not surprised. I do remember it taking kind of half here in the front first. So what we'll do is mount this, properly install it, and torque it down onto the base, and then we'll grind it flat again when it's there. Good news is I am comfortable that the surface here is flat. Well, this surface was unchanged, but that flatness is important because that'll be the part on the base. And then here as well, the flatness of these surfaces compared to my surface plate were really, really close, within half a thousandths. So I'm comfortable that I have flatness. From a squareness perspective, I think that I did some measurements the best I could. I don't have all the right tools to measure total squareness, but I can do a number of visual checks, getting a really nice fit with the 1, 2, 3 blocks up against there. If you do the light test behind it, it's hard to see this. It's hard to see this. I'll rotate it through and see if that helps. I don't know if you can see that, but the squareness test on these was, acceptable in my opinion. For the tools that I have and the skills that I have, I'm quite happy that these are square and parallel. So our next step, given that I'm comfortable with the parts and pieces where they lay now, next step will be reassembly. So let's do that.